Now, let us discuss about extraction of pure metals from ore, using moderately reactive metals. The moderately reactive metals such as zinc, iron, tin and lead, etc., are placed in the middle of the reactivity series. These are usually present as sulfides, or carbonates in nature. It is easier to obtain a metal from its oxide, as compared to its sulfides and carbonates. Therefore, prior to reduction, the metal sulfides and carbonates must be converted into metal oxides. The concentrated ores can be converted into a metal oxide by the process of calcination or roasting. Please note that a carbonate ore is converted into oxide by calcination, whereas a sulfide ore is converted into oxide by roasting. Here calcination process converts ores to metal oxide. Let us briefly discuss about calcination. Calcination is the process in which a carbonate ore is heated strongly in the absence of air to convert it into metal oxide. Example, zinc occurs as zinc carbonate in calamine ore, ZnCO3, that is, zinc carbonate. So, in order to extract zinc metal from zinc carbonate, this zinc carbonate should be first converted into zinc oxide. When calamine is calcined, it decomposes to form zinc oxide and carbon dioxide. Chemical equation for this calcination process is zinc carbonate, which is a calamine ore, on calcination gives zinc oxide plus carbon dioxide. Please note that calcination converts zinc carbonate into zinc oxide. Roasting process converts ores to metal oxide. Let us briefly discuss about roasting. Roasting is the process in which a sulfide ore is strongly heated in the presence of air to convert it into metal oxide. Example, zinc occurs as sulfide in zinc blende ore, zinc sulfide. So, in order to extract zinc metal from zinc sulfide, this zinc sulfide is to be converted into zinc oxide first. When zinc blende ore, zinc sulfide, is strongly heated in air, it forms zinc oxide and sulfur dioxide. The chemical equation is zinc sulfide plus oxygen from air on roasting gives zinc oxide plus sulfur dioxide. Please note that roasting converts zinc sulfide into zinc oxide. Now we are going to discuss about the metal oxides are converted to the free metal by using reducing agents like carbon, aluminum, sodium or calcium. Please note that less reactive metals use carbon agent, whereas more reactive metals use aluminum agent. The oxides of comparatively less reactive metals like zinc, iron, tin, lead and copper are usually reduced by using carbon. Carbon reduces the metal oxide to free metal. For example, zinc metal is extracted by the reduction of its oxide with carbon, or coke. Thus, when zinc oxide is heated with carbon, zinc metal is produced. The chemical equation is zinc oxide plus carbon, as reducing agent, gives zinc metal plus carbon monoxide. Here we are using aluminum as reducing agent, to convert from metal oxide to metals. A more reactive metal, like aluminum, can displace a comparatively less reactive metal from its metal oxide to give free metal. Manganese metal is extracted by the reduction of its oxide with aluminum powder as the reducing agent. When manganese dioxide is heated with aluminum powder, then manganese metal is produced. The chemical equation is manganese dioxide plus aluminum powder, as reducing agent, gives manganese metal plus aluminum oxide plus heat. Please note that the reduction of manganese dioxide with aluminum is a highly exothermic reaction, as producing heat. Here we are using aluminum powder as a reducing agent, to convert from metal oxide to metals. Let us now discuss about thermite reaction. The reduction of a metal oxide to form metal by using aluminum powder as a reducing agent is called thermite reaction. The reactions of metal oxides with aluminum powder to produce metals are highly exothermic, in which a large amount of heat is evolved. This property of reduction by aluminum is used in thermite welding for joining the broken piece of heavy iron objects like railway tracks. Aluminum reduces iron oxide to produce iron metal with evolution of lot of heat. Due to this heat, iron metal is produced in the molten state. The chemical equation is iron oxide plus aluminum powder as reducing agent gives iron metal plus aluminum oxide plus heat.